So, hello everyone. Let's begin our community call. So today we have a lot of updates for you. So first of all, Evgeny Ponomarev, the co-founder of Fluence, will present the updated the roadmap updates and tell what we are going to deliver really soon. Then I am going to present the engineering updates and the stuff that we have already rolled out on our public testnet. We will also have some updates on the events where you can meet Fluence team and meet with us in person. And of course, we will have some Q&A sessions. So, Evgeny, would you like to share the screen, or should I do it?
I think any way works. Hold on 1 second. Maybe I'll share the screen. I'm not sure if it's working. Oh, it's working. Nice. Yep. So like very short update on where we are in terms of our journey. So just a quick reminder what we are doing here. What Fluence tries to do is to build the decentralized serverless platform, and it's kind of wide vision, like the cloud, like the serverless platform and the cloud platform is a big thing, and it includes compute. Like usually, see a lot of cloud services in the big clouds. They're very different. They are following different patterns of like compute consumptions and basically provide different ways to execute jobs or focus Fluence on single use case, basically as analogy to AWS Lambda. So like it's a serverless compute. It's a function as a service analogy. And we split Fluence to kind of several layers. So there's a domain that's kind of like the network of two Fluence, like computer sources, like basically sources are being aggregated as on-chain provider offers and so on and so forth. So like on this on-chain compute marketplace. The other thing is developer platform, which means this products for developers who are going to consume this compute capacity from the marketplace. And this is currently is like basically the experience of developer platform is very similar to Amazon Lambda, which functions as a service. And then we have some show on top of the developer platform to show wide variety of stuff that can be built on Fluence. And when Fluence is launched, it's going to be managed by the DAO, so it's going to be the fully decentralized network and decentralized is a so we kind of map our stack to traditional terminology and traditional way of thinking about serverless and stack correspond. I guess yeah. So like what we focus on right now is delivering Lambda experience. Like some of these things will not be delivered short term, but will be will be delivered long term. So for example, auto scaling doesn't exist yet, like because we have only WASM, many additional languages that people used to have in Lambda. Sorry, yeah. And so on and so forth. So yeah, and like a lot of data integration because it's about console doesn't these like built-in databases or this stuff. We integrate in databases with storages. Initially, it's integrated with IPFS and blockchains, but like in the future, it's basically should be integrated with any potential data. As I said,
Seems like Evgeny's connection is not very good. Let's wait for him to return to the call. Just a sec.
okay, that was weird. I was disconnected. Hold on. Can you hear me,
Yes,
guys, now?
but maybe you can disable your video. So
right. Yeah, let me disable video, but I still need screen sharing. Okay, I'll see if I disconnect again, then probably I would ask you to screen share, and I'll use mobile connection. All right, Compute Marketplace, providers, offers, deals, payments. So like basically a way to deploy your applications to some providers. You make an on-chain deal with these providers, and they serve your application. This includes collateral and they get payments like in a default way in stablecoins. So customers pay in stablecoins, but potentially could be like an ERC20. That's how we design it. It looks like this. So on-chain deals, providers register some offers with resources that they have with different pricing, and it's all connected to their physical servers where they run Fluence nodes, and every Fluence nodes makes busy with some work and some unallocated workers. So is verifiability and incentives. So we have we separated to several things. We have proof processing, proof capacity, and in the future we'll have proof execution. What does it mean is that because we run all the computations, proof of right Aqua execution is proof of processing, and it's being probabilistically validated on chain. This is something that is in progress and probably will only be done next year. So like some of this will be already done within some cryptographic validation, but on-chain validation probably going to be done next year. Proof capacity is our way to incentivize compute providers to connect servers, connect their capacity to a network, even if this server will not be yet busy with customer jobs. So they will execute some rewarded in Fluence tokens. And proof execution, it's proofs around WASM. Actually have slide for everything. Like this is proof of Aqua execution. It's probabilistically done. We basically take one of like sampling particles and sending them on chain, validating them on chain, and those are in this cycle. Proof capacity, it's a proof work analogy based on ladders for submitting capacity. So like the more kind of servers you have and connect to network, the more rewards share you receive. So yeah, so the most important slide here is this kind of roadmap is where we're going to have like a basically switch to production to get the production state in this winter. So it basically means on-chain mainnet, it means off-chain mainnet, like all together mainnet. It requires some things to be finished. And it should be like Aqua, basically like all the developer experience in a good shape. We just announced it's the way how we deploy basically customer functions. They've been deployed, they're replicated, like basically like several copies of function to several nodes. So you can have fault tolerance. On Compute Marketplace, the Compute Marketplace should just be finished. It's now in development. And proof capacity needs to be transitioned to the production to the line. So we see a lot of improvements that could be done both on for developer experience and for marketplace. So all kind of data integrations, other runtimes like Docker or other languages, support of GPU integration with like a lot of stuff. And for Compute Marketplace, a lot of important things like liquid staking, ability to pay in fiat via some gateways, some attestations for certain computations. So also like a big roadmap here. So excited to launching it, and excited about a lot of stuff that is still needs to be built, that will onboard more and more use cases and bring more and more value. Yeah, so I think that's it from my side, and I will give it to Fedor.
Evgeny, thank you. So there was some connection problems, but probably most of the stuff was heard properly. So hopefully, let's switch to the network updates. So we released a huge network updates into our Crust network. It includes all the latest features we've been working on throughout the year, and the protocol became more secure, performant, and closer to feature completeness. And let me just walk you through the stuff we've been working on and the stuff that we've released. So first of all, subnets. We introduced updated subnets. So basically, they are replicated deployments for your applications, and they allow you to add qualities like fault tolerance, consensus, and load balancing to your functions or services deployed on Fluence network. And every time you deploy an application to Fluence network, you are defining a subnet configuration, basically the amount of peers, acceptable pricing, and so on, and have your code deployed to a specified amount of peers. And subnet peers follow the coordination code that you write with Aqua. And you can implement failovers, consensus algorithms, load balancing across the peers, and other distributed scenarios. And subnets are tied to on-chain marketplace deals, where all the participating peers on the subnet are configured and managed. So we will have the links to the descriptions on how to work with subnets on the upcoming slides. So as you can see, subnets are not only gives you the fault tolerance, but it's also a path to the application protocol composition. So for instance, you can have a subnet that gathers data from IPFS and uses the data source. You can use another subnet for data processing and another subnet for aggregating data and loading into data warehouses. And basically, you can use Fluence Network and Aqua to move the data between those protocols and make it available for your applications and have those composition flows available. Another update is that we have renamed our Rust peer to Nox. So basically, we've done a significant revamp of it. We also added support of M1 and M2 Max and 64-bit ARM architecture support, so that developers could run local development environments on their machines. Right now, it also comes with the HTTP-based health check endpoints that you can use to run our Nox in production-grade environments. And you can use this QR code to get the list of the changes that we've made to the Rust peer. So please take a look. We've done a tremendous job, and especially thanks to our network team. So we also added a new feature to our Aqua language, and we have Mikhail on our call who will tell us about this. Mikhail?
Yeah, sure. Can we skip this slide? It's rather irrelevant. Yeah. So we've been putting a lot of effort to make Aqua more developer-friendly, future-rich language, and I will show you a brief overview of what's been done. Next slide, please. So the biggest update is abilities. What is ability? Ability is a new type in Aqua language, which can hold virtually any type inside it, which Aqua have, except for service types. Here on the left, you can see an example of defining an ability type. You can see it holds arrows, other abilities, structs, and primitive types. Next slide, please. Yeah, how could we use them? Any function in Aqua language that is not exported to outside world can accept an ability, but not as a simple argument, but with new syntax you can see on the left. It is abilities that function accept are defined in curly braces. Yeah, and on this example, you can also see how to create abilities and use them. Their creation resembles creation of structs, and their usage is much like you would expect. They have dot notation for accessing fields, like any of them, arrows, other abilities, so on. You can also see how to pass an ability to a function on the last line in curly braces too. Abilities have structural subtyping, so you can pass an ability everywhere another ability is expected if it is subtype by structural typing. I think next slide. Yeah. Worthy to note, abilities are fully resolved at compile time, so they have some limitations. You couldn't put them in a collection, for example, and you couldn't export them to JavaScript or TypeScript, for example. And let's for a second switch to the previous slide. One could ask why new syntax for abilities. The ideologically speaking, abilities are way to structure your code and implement inversion of control pattern in Aqua. So new syntax is given to them so that it emphasizes that abilities are kind of contexts. So when you're writing, when you're demanding an ability for a function, you are saying that your function demands some context to be run. It is services work as abilities right now, so you can pass a service as an ability if it structurally matches the ability. But it is the most basic usage. We are on designing or implementation phase of more support for different features for abilities. For example, whole libraries could become an abilities. And probably abilities would provide some support for our already discussed subnets and workers, so that it will help write clean code, clean understandable code, and make less mistakes in Aqua. Yeah, next slide and next slide. Other features include error handling. Now errors are propagated through topology, so developer could handle them at developer could handle error that was raised in on any peer. It would propagate back to you, to your initial peer, and you can handle it. Next slide. Also, now if blocks propagate errors too, and those two features make errors a great way to actually structure your code, control your code flow. They work just like you would expect in any other language, but Aqua is executed on different peers, so it's pretty awesome that errors are propagated transparently. Yeah, next slide. Also, for your convenience, we added full-blown Boolean algebra to our language. Not much to say here. It works just as you would expect in any other language. Yeah, next slide. And also to enhance developer experience, we introduced warnings to our language. It is already supported by our VS Code extension. So it will notify you as a developer of any anti-patterns in Aqua code, for example, or possible sources of errors. That's it. Of course, much more was done. You could always check our changelog, detailed changelog in the docs. I guess that's it for me.
Yeah, Mikhail, thank you so much for such a detailed description of abilities and the Aqua updates. So let's continue with the stuff we've already rolled out. So the next thing is the updated Marine.js. We finally released multi-module feature to Marine.js. Now it can reuse the same code as Rust Marine implementation. And basically it makes those two environments that we have, the Rust peer and the browser, pretty similar and equal in terms of possibilities of code execution. We also made some huge updates to Fluence CLI. So we really tried to make our developer tooling really user-friendly and really convenient. So we added, so first of all, we moved our CLI and tooling to the Node 18. So right now it doesn't require Node 16, it uses Node 18. We also added and integrated the Air Beautifier tool that will help you to read the compiled Air scripts that you can use for debugging. Also for debugging and tracing purposes, we added Aqua tracing to the Aqua compiler. So basically it will allow you to get the logs, the flow actually works. It's really useful for debugging your decentralized algorithms. Also, we added the update checks for CLI, so you will be notified when we have released the new versions of Fluence CLI. And as you can see, we vastly improved the functionality of Fluence CLI by adding the ability to manage the providers. It is the thing that Evgeny was covering about moving our network to the state when you can start trying and testing, running your own providers on our network. And right now, all the project files that are scaffolded with Fluence CLI are annotated, and you can actually, and we made it much easier for you to understand what's happening there and what you can change. So for core protocol updates, we have Roman on the call.
Everyone.
So yeah.
So my name is Roman, and I'm from Machines team at Fluence. I will briefly touch the recent changes in the distributed virtual machine. The major change is introduction of CRDT-like maps. We have two goals in mind, actually, introducing this feature. The first is to improve the structures handling in Aqua language. And the second is to supply Aqua language with map-like primitives for future development of the language itself. And the byproduct of this introduction was an unexpected reduction of to JSON conversion overhead. Can you switch to another slide, please? So in a nutshell, there are two flavors of maps. As for the stream types that the distributed virtual machine already has, the maps are either mutable or immutable. And on these slides, I will tell you about the mutable maps features. Internally, it is a stream of key value objects that you can see at the first bullet. And these objects basically have two keys inside internally, the key and the value. As you can imagine, the values for these keys contain the actual values. Just to mention, the key can be either a numeric or a string. The supported operations for these mutable map flavor are insert. You can insert the value into the map, and very unfortunately with this release we have only manual way to add the key value into the map, but we will surely make faster ways to filling up maps inside Aqua VM. And the second operation is iteration over the map contents. Given that the map is mutable, so technically it is possible to populate the map itself while you are iterating over its contents. However, I don't suggest doing this. With the B bullet, you can take a look at the example syntax of how you can iterate over the map in air. And the third operation is to turn the mutable map into a immutable canonicalized map. Next slide, please. Immutable, yeah, let's touch this part. Immutable maps are also of two kinds. The first is a scalar representation that resembles JSON object very closely. So you can basically turn the map into a JSON object and to send it as a service argument. You can see how would the operation change the internal representation of mutable map and produce the a common JSON object result. Next slide, please. The second flavor of the immutable map is a fully canonicalized map. And the major difference is that you can access the attributes or elements of this map separately. So you can see in the bullet I small how to access the elements of a specific canonicalized map, and even get further and access an attribute of this key. The second operation that you can apply for a canonicalized map is the same fold. The only and main difference between the mutable and immutable maps iteration is that the canon map, it is fixed at a certain map, at a certain node. So you can have the same context, the same contents of the map. You can be sure it will not change over time. Next slide, please. Yeah, so this is all from Machines team. Thank you for your attention.
Roman, thank you. So what's that all that mean for you, the developer? So first of all, everything that we've covered in this presentation is already available on our public testnet, and you can try it. It's more stable, performant, and developer experience was improved. It's actually really smooth developer experience right now. Please try it. It's really good. It's ready to be tested, and you can just update to the latest builds of everything if you have been using our tooling previously. If not, then you can go and try our quick start, read the documentations, or even try some of the example application that we've prepared, such as FRPC. It's our DRPC app that we've created with Fluence. And if you have any questions, or if you have tried it and something didn't work for you, or you want to suggest something to us, to the team, or you just want to chat with us, so please go to Fluence chat, go to our Discord channel, and we'll be more than happy to answer all the questions, or even have some workshops. So guys, please try it. We have done a huge work, and it's really awesome right now. So right now I'm gonna pass the mic to Nadia.
Yes, while the developers team was working on all of these updates, our let's say business team and the business development team have been participated for the whole summer, and still participating in many events, making useful connections, talking to the audience, talking to different developers, and give a lot of talks and workshops explaining what Fluence mean and how everything works. So yeah, the last time we met each other, we've been preparing to ECC Paris, so it was successfully passed. We had a lot of discussions and talks, and yeah, many different connections made on ECC Paris and all the side events around, such as Filecoin, Network Base, and EdCon. So yeah. Also, there was recently Field Dev Summit in Iceland. Maybe some of you been there also and met our team there. Fyodor gave a talk at DebCon Berlin, presented us for like Ethereum community of DIA builders. And recently we've been to Talking 2049 in Singapore, which is like the biggest Asian event, or maybe biggest event at all, with like 10,000 people attending. So, and right now, can we go to the next slide? Yeah, and next slide as well. All right, yeah, so right now you can go to our YouTube channel, and all the talks that we gave at all of these events were recorded, and you feel free to watch anything, feel free to ask questions and comments. We already published pretty much everything. Like, we have all the recent talks there. So for some of them, we will present in our recent updates as well. So yeah, feel free to watch. And the next slide. Where to see us in the nearest future. So right now we are in Las Vegas. I mean, like most of part of the team. They're attending at Feel Vegas and ESPA Accelerator event, explaining Fluence to Filecoin developers and storage providers. Bernard gonna give a talk in All Things Open conference for open source developers in United States. And yeah, so the biggest event is coming on November, and we're gonna have a staking summit during the DevConnect. We're gonna be attending the DevConnect co-working, and we're gonna organize our own decentralized RPC summit together with many different partners. So yeah, like more listed on the next slide. Yeah, next slide. So yeah, this is the event that we are going to organize during the DevConnect week in November. Feel free to join us. Feel free to apply for a speaking slot if you'd like to participate as a partner or speaker. Pretty much everything in this QR code. And if you go to this DevConnect calendar, you can find this event already there. So yeah, we'll be happy to see you in Istanbul. This is the place where like pretty much all the people can travel to. Yeah, so use this opportunity to meet our team, and we'll be happy to see you there. Oh yeah. Yeah, we have a pop-up of today's call. So while we're gonna have a Q&A session, I will just send all the links to your DM. Because it is unique, so I'll need to take some time. And that's it. So I pass my word to Fyodor back.
Okay, thank you, Nadia. I think right now we have a Q&A session. So regarding the questions, does anyone has any questions?
We have some in YouTube.
Okay.
Yes, we have a few questions from Jora. I don't know why, but he cannot join us in Zoom. Some Zoom updates again. Let me just ask them right now, so someone will be able to answer. The first question is, what does it mean for devs, for developers, platform to be off-chain? Are there no deals? Who can answer?
No, so I can answer it. So Evgeny already have posted it in the chat, but I will repeat it. So first of all, we have our deals on chain, but the actual execution of the code is off-chain. So the code that is executed through Marine, the functions themselves are executed off-chain. So, but all the economy, the compute marketplace exists on chain. So hopefully it answers this question.
All right. He has another one. These are off-chain marketplace deals. Okay, so probably he has a lot of questions during the whole call. How do abilities relate to distribution within subnets? Do subnets use built-in abilities?
So
I can answer.
Great.
Abilities are mainly about organization of the code. So if you want your code to be organized, your Aqua code mainly, and reusable and easy to test and so on, probably you want to employ inversion of control pattern. And for that, we have abilities. Abilities are resolved on compile time, which means that during the execution, there is no glance of abilities in the generated error code. Maybe in the future, we will have special abilities for workers and subnets that will have some trace in the error code, but currently there is nothing. So it's only about organization of the code. But if you want to create a subnet and to use it in the composition with the other subnets or as a building block, as the bottom layer for improved subnets, like how Fyodorov shown it, or in some other way, then probably you want to organize your Aqua library corresponding complementary to your subnet in the form of ability, so that it's easy to use, it's easy to compose, reuse this code, and so on.
All right, so I'll just drop some more questions for you to be ready for it. So the next one, can you elaborate on lessons learned with regards to off-chain versus on-chain marketplaces?
Well, I'm not sure what this question means. Like, I mean, the way Fluence works is that we're organizing the servers, basically, like the compute capacity from different providers into a network. And then, developers is able to execute code on this network using Fluence developer toolkit, and basically using Fluence sort of cloud services, like serverless cloud services, deploying these services on this hardware. So, and this all off-chain. So this is not a blockchain. This is like a peer-to-peer network, right? But then the deals between these developers and providers happening on-chain, and these deals are like needed to basically write down that this particular customer expect from this list of providers that they serve this piece of code for this particular price, and like for this particular time. And this deal is made on chain, so it means that there is a representation of providers on chain. There's a representation of customer on chain, so they can create a deal and transact. So this is how Fluence works. So the network is off-chain peer-to-peer network, but the marketplace is something that exists on-chain as a registered providers, deals, transfers like payments, and so on and so forth. I hope I answered.
Yeah, I think it's like some sort of a second part of this question. Are subnets already using built-in abilities for its inner orchestration?
Well, abilities are the way to organize the code. I'm not sure if the subnet code is already organized with abilities, but the concept is that when we say that you can plug this or that emerging behavior to your subnet, supposedly it means that when we get more code written with abilities, which is a very new feature. We will have subnets organized with abilities, which will be different. Like you could have a member list ability, raft ability, consensus ability, whatever ability. And now subnets are still using the built-in services like it was before for their organization. But these services are different. It's not registry anymore. It's reading from the chain. So all the workers, all the peers of the subnet are registered on chain, and for discovery, they are read from the chain. I hope that this is what Yura means.
Yeah, Yura, let us know if you have any more questions. So we're still here to answer. And yeah, one more. So when I update the Knox nodes on my home server, that network should I connect? What network should I connect to? And what would be most practical choice for the inner IPFS peer, localhost or one from Fluence?
I suppose that you want to connect to the cross network as the most long-living one, and you want to take the default IPFS peer. It should be ipfs.fluence.dev, I suppose. And you should also connect to the right chain node. So I'm not sure if we have documentation on this, but reach out to us if you need any help with that.
Yeah, so actually the next question is, what's the progress on the documentation? So
we actually released the updated quick start guide that helps developers to get up to speed with the new subnets, with the new on-chain matching of compute peers and deals. So please go to fluence.dev, please go to build quick start, and there will be a detailed quick start guide on that. And I also send the link to the chat right now, and Nadia could post it to the YouTube comment session.
yeah, that's right. So that was the last questions from Yura. And just one comment that see you in Istanbul. So we'll be happy to see you, Yura, in Istanbul as well. Yeah, maybe with some delay, we're going to have more, but yeah, I think that was the last question from Yura. Somebody is raising a hand.
Yeah, I have a question to Mike Vorobyov and language compiler team. Do you have some plans to implement tree-sitter for Aqua so that other editors IDE can work with it, and also LSP server for same reason?